Next, what is the expression for corona power loss? So the first one is called as Peake's empirical formula. So this is valid only when the ratio between V and Vd is greater than 1.8. That means this is the operating voltage, V is the operating voltage and Vd is the critical disruptive voltage. This is operating voltage and this is critical disruptive voltage. So this is Pc is equal to 241 into 10 to the power minus 5 F plus 25 divided by delta root over R by D V minus Vd whole square. So the units here are kilowatt per kilometer per phase. Okay. So what is F here? F is the frequency of power transmission. So usually it is 50 Hertz, right? In our country, the frequency of power transmission is 50 Hertz. And V, like we already discussed, it is the operating voltage in kilovolt. Okay, it is RMS value, kilovolt per phase. And finally, Vd is also the same thing. Vd is the critical disruptive voltage in kilovolt per phase. Okay. Now, what about the case when V by Vd is less than 1.8? So here the losses are going to be less, and a formula which is going to give a better accuracy is the Peterson's formula. So this is given by Pc is equal to 21 into 10 to the power minus 6 F V square capital F divided by log D by R. This is to the base 10, okay, whole square. So this units also same as before, kilowatt per kilometer per phase. One new term that you see here is capital F. So what is that? It is the corona loss function. So it will depend on the operating voltage, which varies with the ratio V by Vd. So these formulas may seem very complex, but don't worry, these are not very important in the gate point of view. Next we are going to discuss factors affecting the corona loss. So this you can get some idea from the expressions itself. So even if you're not remembering the formulae, the entire expressions, if you can remember what are the factors affecting corona loss, that is more than sufficient. Okay. So the first one is system voltage. So the losses will start only when the operating voltage is greater than Vd. Okay. So only when V greater than Vd, corona losses will start to occur. Okay. So what will happen? As voltage increases, the corona loss will also increase, right? Because there will be greater ionization as the voltage increases. So there will be greater amount of losses. Second, what is the dependence on critical disruptive voltage? So critical disruptive voltage, it is more or less constant, but it also depends on some factors, right? And higher the critical disruptive voltage, lower will be the corona loss. For operating voltage V greater than Vd, as Vd increases, the corona loss is going to reduce, because the difference between V and Vd is going to reduce, right? So the loss will also reduce. So now what are the factors that are affecting the critical disruptive voltage? So the first one is the weather. So during rain and storms, the critical disruptive voltage, it is reducing. Okay, corona will more easily be formed. Okay, during rain and storms, Vd will reduce. And second is the configuration of conductors. So let us say you have 3 conductors and the conductor which is in between, it may experience more amount of electric stress, right? So this middle conductor is going to experience more stress because of these both conductors as compared to the other 2 conductors. So what is going to happen when the electric stress is going to increase? The disruptive voltage is going to reduce. Matlab at a smaller value of voltage, the corona is going to start. So you can write down here the conductor placed in between 2 conductors, the 2 conductors will have more field associated. So when there is more field, there is more stress. So the critical disruptive voltage is going to be reduced. Okay. Now the next point is, this is about critical disruptive voltage. The next point is the frequency. So as frequency increases, the corona loss is also going to increase. Okay. And the fourth factor is the air density. That means this is also more or less the atmospheric conditions. So what happens? The air density is related to delta, right? So as delta increases, the corona loss is going to reduce. Finally, the most important one is the radius. So from the formula for power loss, it may seem that as radius increases, the losses will also increase. But what is going to happen? The radius is also going to affect the critical disruptive voltage. Okay. So the cumulative effect of radius, of an increase in radius, is to reduce the losses. Okay. An increase in radius, reduction in corona losses. So this is where the bundling of conductors is used, right, to reduce the corona losses. So bundled conductors have higher GMR, or you can call it self GMD. Okay, they have higher GMR, therefore lower corona loss.